Suppose n resistors, R1, R2, and so on till Rn, are connected in series in circuit 1 between points P and Q, and a battery providing a potential difference of V is applied between points P and Q. In circuit 2, suppose the series combination of n resistors is replaced by an equivalent resistor, Req, between points R and S, and a battery providing a potential difference of V is applied between points R and S. The figure shows circuit 1, where a battery of V volts is connected between the points P and Q, and the resistors R1, R2, and so on till Rn connected in series between the points P and Q. Circuit 2 has a battery of V volts connected between the points R and S, and the resistor Req between the points R and S. There is no other path for the charge to move to. Also, there is no other path from where an additional charge can enter the circuit, so the current flowing through all the resistors will be the same. Say a current, I, flows in the circuit 1. The same current, I, will flow through the resistor Req. The figure shows in circuit 1, the same current, I, flows through the resistor R1, R2, and so on till Rn. Also in circuit 2, the same current, I, flows through the resistor Req. That is the current flowing in circuit 1 and in circuit 2 is I. So, the potential difference V1 across the resistor R1 is given by V1 equal to I into R1. The potential difference V2 across the resistor R2 is given by V2 equal to I into R2, and so on till the potential difference Vn across the resistor Rn is given by Vn equal to I into Rn. The potential difference Veq across the resistor Req is given by Veq equal to I into Req. The figure shows in circuit 1, the potential difference across the resistor R1 is V1. The potential difference across the resistor R2 is V2, and so on till the potential difference across the resistor Rn is Vn. Also in circuit 2, the potential difference across the resistor Req is Veq. So, the potential difference between P and Q is V, equal to V1 plus V2 plus so on till Vn. The potential difference between R and S is V, equal to Veq. So, Vq, equal to V1, plus V2, plus so on till Vn or I into Req, equal to I into R1, plus I into R2, plus so on till I into Rn, or Req, equal to R1, plus R2, plus so on till Rn. Note, Req is greater than R1, or R2, or so on and so forth till Rn. Suppose n resistors, R1, R2, and so on till Rn, are connected in parallel in circuit 1 between points P and Q, and a battery providing a potential difference of V is applied between points P and Q. In circuit 2, suppose the parallel combination of n resistors is replaced by an equivalent resistor, Req, between points R and S, and a battery providing a potential difference of V is applied between points R and S. The figure shows, in circuit 1, a battery of V volts is connected between points P and Q. Also resistors R1, R2, and so on till Rn are connected between P and Q. In circuit 2, a battery of V volts is connected between points R and S, and a resistor Req is connected between R and S. In circuit 1, the battery and all the resistors R1, R2, and so on till Rn are connected between the points P and Q, and the potential difference between P and Q is V, so the potential difference V1, V2, and so on till Vn between the resistors R1, R2, and so on till Rn is the same, that is, V1 equal to V2 equal to so on till Vn equal to V. In circuit 2, the battery and the resistor Req are connected between R and S, and the potential difference between R and S is V, so Veq equal to V. The figure shows in circuit 1, the potential difference across R1 is V1. The potential difference across R2 is V2, and so on till the potential difference across Rn is Vn. In circuit 2, the potential difference across Req is Veq. The current I1 through the resistor R1 is given by I1 equal to V1 by R1 or I1 equal to V by R1. The current I2 through the resistor R2 is given by I2 equal to V2 by R2 or I2 equal to V by R2. The current IN through the resistor Rn is given by IN equal to Vn by Rn or IN equal to V by Rn. The total current in circuit 1 is I equal to I1 plus I2 plus so on till IN. Same I current flows in circuit 2. The current I through the resistor Req is given by I equal to VEQ by REQ or I equal to V by REQ. The figure shows the total current in circuit 1 is I before splitting into I1, current flowing through R1, I2, current flowing through R2, and so on till IN, current flowing through Rn. The current in circuit 2 is I, the current through REQ in circuit 2 is I. So, the total current in circuit 1 is I, equal to I1, plus I2 plus, so on till IN, equal to V by R1, plus V by R2, plus so on till V by Rn. The current in circuit 2 is I, equal to V by REQ, so, V by REQ, equal to V by R1 plus, V by R2 plus, so on till V by Rn or 1 by REQ, equal to 1 by R1 plus, 1 by R2 plus, so on till 1 by Rn. Note, REQ is less than R1 or R2 or, so on till Rn. The figure shows in circuit 1, the potential difference across R1, R2, and so on till Rn is V.